All right. The next thing we're going to do is we're going to look at this part in your notes right here. Determining an unknown half reaction voltage. So sometimes in a problem you're going to have maybe an unknown metal, or you don't know half of the story, right? You know the oxidizing agent, but you don't know the reducing agent, or vice versa. That's kind of what's going on in these sorts of problems. So if we take a look at this problem right here, you see that you've got Ge solid, which we now know is our anode. Ge4 positive is its electrolyte. Copper 2 positive and copper solid are the other half reaction electrolyte and electrode. And it tells us beside there that the net voltage, or the E net for that cell, is positive 2.36 volts. So this is a voltaic cell producing 2.36 volts. But copper is on my half reaction, Ge is not. So that's what I'm trying to figure out here. What is the reduction potential for the Ge? Because it's not on my data booklet, or it's not in my data booklet, it's not on any tables, so how do I figure that out? Okay, so let's jump into this. Let me just pause for a second and fill this in. Maybe? Nope. Let me try again. Over here. Okay. Now I think we got this going. So let me see if I can bring this back though. Where did my drawing go? There we go. Alright. So if we take a look at this. Oh, there we go. If we take a look at this is what the question gives me. So we've got this information. Now remember that I know that this is the anode, right? Because it comes first. And if it's the anode, right? Remember Leo Anderson, or however you want to remember that. So that also means that this side, either the Ge solid or the Ge4 positive, is being oxidized. Because it's being oxidized, one of these two is the reducing agent. Okay? And we could figure out which one right now, right? Which one's being oxidized? Which one's losing electrons? So if Ge solid loses electrons, does it become Ge4 positive? And yeah, in this case it does. It loses those negatives, it becomes more positive. So Ge solid is my reducing agent. We can do the same thing on the other side. Copper solid I know has to be my cathode, which means something over here is gaining electrons and being reduced. That's why the cathode's over here. And if we look at which one would be gaining electrons, the copper 2 or the copper solid. Now we looked at that one just kind of intuitively. Let's use oxidation numbers just for practice. This would be a +2, this would be a 0. So it's the copper 2 gaining electrons to become copper solid. So this one actually would be my, OA. All right? Now, because copper is my OA, I would normally write its half reaction forwards, just like it is in the data booklet. Okay? So I would write, copper 2 positive plus 2 electrons becomes copper solid. Okay? And because I wrote it forwards, just like it is in the data booklet, I'm going to keep that voltage right there. So it's a positive 0.34 volts for that half reaction. Okay? Jump back to my drawing, which I just filled in. All right. Now the Ge, though, I don't know. It's not in my data booklet. But I know that the reducing agent is the Ge solid. I know it's becoming Ge4 positive, which means it's got to be losing 4 electrons. That's the only way that that makes sense. But this voltage right now is an unknown. Now the question doesn't ask for it, but we could, just for practice, figure out this net reaction. Okay? So if we cross out, to combine our two reactions, we first have to balance electrons. So this one right now is gaining 2. This one's losing 4. So to make that work, we're going to multiply this reaction by 2. Now it's gaining 4 and losing 4, so we can cancel out our electrons. So now we can write our net reaction, which is 2 copper 2 positives plus a GE solid becomes 2 copper solid plus GE 4 positive. And I know that the net is given to me up here in the problem. So I know this has to add up to positive 2.36 volts. So now I have enough information that I can work backwards to solve what that unknown voltage for GE was. Because I know that whatever it is, those two numbers have to add up to 2.36 volts. So that gives me a positive 2.02 volts. Now here's where you have to be a little bit careful though. If we're looking at this, remember that on our data booklet we wrote the copper reaction forwards, which is, this is a table of reduction half reactions. So that forward one is a reduction half reaction, which means this one is an oxidation half reaction. So right now this number for the copper right here, because that's a reduction half reaction, that's a reduction voltage or reduction potential. But this one, because it's an oxidation half reaction, that number is an oxidation potential. And if you look back at the question that we were originally trying to solve, it says determine the reduction potential of the GE, not the oxidation potential. So reduction potential would essentially be to grab that reaction and flip it. So the answer to the question isn't the positive 2.02 volts, it would actually be negative 2.02 volts. That would be the answer to the question. Okay, because it was asking for reduction potential. Okay, so on these ones, remember to keep straight, cell notation, anode on the left, cathode on the right. That helps you figure out your OAs and your RAs. Some will be very similar, or simple, like these ones, where you can just tell whether they're losing or gaining by looking at them. If they're more complicated, use your oxidation numbers. Assign them and you can track your electrons that way. Okay. Once you do that, then it's essentially over here just some basic arithmetic, finding out the unknown value of whatever you're missing. Okay. And then just always be careful, if their question is asking for reduction potential, make sure that the one you're solving for is a reduction potential and not an oxidation potential. Don't forget to flip those if you need. If you have any trouble, let me know. If you have any questions, feel free to contact me.